The next important chapter is fractional part conversion. We have converted up to now how to convert a particular decimal number. The whole number we converted from one type of number system into another type of number system. Now we are going to convert the fractional part conversion. Okay, how to do a convert a fractional part number in a computer system. So the first one is rules for conversion from decimal to binary with fractional part. Okay, converting the integral part of decimal to binary equivalent as it is. So now how we are converting a particular decimal number to binary, as we mentioned in the above slide, in the same way you have to divide it by divided by 2 and divided by 2 and take down this remainder and take from top to bottom to top. We are just converting, right? So in the same way we have to convert the whole part. Okay, that's why I mentioned here converting the integral part of decimal to binary equivalent as mentioned in the above slide. For example, you consider here 55.375. So now consider here 55.375. This is the whole part, right? This is only the fractional part. 375 is the fractional, right? This is the fractional part. This is the whole part. So whole part normally we are divided by 2 divided by, we are doing the whole number, right? So in the same way, take down this 55 and divide by 2. 27 2s are 54 and the remainder is 1, and then 2 and then 13 2s are 26, remainder is 1. Then again divided it by 2, 6 2s are 12, remainder 1. So divided and write down this equivalent binary value 110111. Okay, so the equivalent binary for 55 is 110111. Okay, this we have seen already in the previous slide. So now we have to convert the fractional part of decimal to binary equivalent. So how to convert a particular fractional part? So 0.375 is the fractional part. This is a whole number part and this is the fractional number part. So fractional number point is 0.375. Okay, multiply the fractional part decimal number by 2 by its base of its value. So decimal to binary. So now I am going to convert into the binary value. Binary means base is 2. So you have to multiply this fractional part into 2. So 2 into 0.375, that is equal to 0.750. Okay, take only this overflow number 0 you have to take down. Okay, and then this 0.750, that is this 0.750 into 2, that is equal to 1.50. Okay, so and then this overflow after before decimal you take here and keep it in this overflow section, and in the next step you have to take 0.50 only, not 1. Okay, only the fractional part you have to take. 0.50 into 2, this. So this fractional part becomes 0. This, when the fractional part becomes 0, you have to stop the process and write down from bottom to top. This is from bottom to top. Normally we are written as top to bottom. This is the whole part, top to bottom. Okay, so when you want to write down the fractional part, you have to write it from bottom to top, from up to down. 0 1 1. So 0 1 1 is its equivalent binary value. So converting the integral part and fractional part from decimal to binary we came to know, right? So convert the integral part of decimal to binary equivalent as it is in the, which is mentioned in the previous slide, and convert the fractional part of decimal to binary equivalent is multiply the fractional decimal number by 2, or we can also call it as base of number. So base of this binary is 2, that's why we are multiplying this fractional part by 2. Then the next step is integral part of resultant decimal number will be first digit of the fractional part. See, this is the resultant decimal value, this overflow number, right? This is the first digit of the fractional number. This is the first digit of the fractional binary number. Okay, repeat step 1 using only fractional part of only fractional part. Okay, remember this. We have to repeat again, multiply by its base value by multiplying only its fractional part. 0.750 only, here 0.50 only, to the next step 0.50 into 2. Don't touch this overflow number. Okay, so multiply the fractional decimal number by 2. The next step is integral part of resultant decimal number will be first digit of a fractional binary number. So this is the first result of a fraction binary number. Then repeat step 1 using only fractional part of decimal number, and then step 2. Okay, so this in this way you are converting from decimal number to binary equivalent in this fractional part. So the decimal value is 55.375. The binary value is 110111.011 is the equivalent binary value. And the next one is the same rules for conversion from decimal to octal with fractional part. Previously we are converted decimal to binary conversion with fractional part. Now we are converting from decimal to octal fractional part. So how to convert from a decimal number to octal? We are just mentioned in the above slide, right? So as we mentioned in the above slide, divided it by 8. Divide by 8, write down from bottom to top 143. Here you see taken the number 225.225. So this is the whole part and this is the fractional part. Okay, so the whole part you have to convert as it is. Then take the fractional point 0.225, multiply it by 8. So multiply it by 8, you will get 1.800. Okay, take this overflow 1, okay, only this one, and write down here. And we have to, in the next step, take down only the fractional part 0.800 into 8. So the resultant is 6.400. So to write down this 6 here, this overflow number, and in the next step you have to take only this fractional part 0.400 into 8, that is 3.200. Then this 3 you have to out and take down the 0.200 into 8, that is 1.600. Okay, so in the same way if you take, you will get this fractional part. You have to write it bottom to top, sorry, one minute. So when you are going to write down this fractional part, you have to write from top to bottom. Okay, top to bottom. Whereas in this fractional part, you have to written as bottom to top. Okay, so the equivalent value of 225 part 225. Okay, that is the whole part is 143. So 143. Now we have to written as 3 bottom to top, right? That is 3 you have to write first, and 4 and then 1. Okay, from here fractional part from top to bottom you have to write. So 341.16314. 16314 is the answer. Okay, convert the fractional part of decimal to octal equivalent is multiply the fractional decimal number by 8. Multiply this fractional decimal number into 8. Okay, integral part of resultant decimal number will be first digit of fractional octal number. You have to take this one as the first fractional number for this. Okay, that's they have mentioned that only. Repeat the step 1 using only the fractional part of decimal number, and then step 2. So repeat the steps until it becomes 0, or you can stop the process once you received 5 decimal places or 3 decimal places. Depends on the question, you can stop the process also. Okay, so these are the steps to convert a decimal to octal fractional point. This is a fractional point conversion. So decimal, just you are doing as it is, and this fractional part you have to take it, multiply it by 8. Multiply it by 8, or you can also call it as base of that number. okay, base of octal. So base of octal, multiply it by base of octal, and from top to bottom you have to take down this and x. Shall we go to the next one? Yes. Rules for conversion from decimal to hexadecimal with fractional part. So how to convert from decimal to hexa? As usual, we are already mentioned in the above slide. So just 374, take down this 374, divide it by 16. So when you divide it by 16, remainder is 6, and here 1 16s are 16, remainder 7, and 0 16s are 0, 1. So this is an integral part. This is the integral part, 374.37. Okay, so the integral part conversion is 176. Write down as it is. Okay, then to convert the into fractional part, decimal to hexa, sorry. So to convert a fractional part of decimal into hexadecimal equivalent, multiply the fractional decimal number by 16. So take down this 0.37 and multiply by 16. So take down this 0.37, multiply by 16, you will get 5.92. Okay, you take down this carry 5 as it is, and take the remaining fractional point 0.92 into 16 and multiply it again, and take this overflow 14, carry 14 is called as E. Then in the next step, take down this 0.72 into 16, then you will get 11.52. This 11.52 you have to take only 0.52 for the next process and leave this 11, okay, carry 11 as B. And then here this is 8. So 8 you have to take. So 0.30, I am stopping this. So from bottom to top I have to take. So the first one is 5 and 14 will be called as E, and 11 will be called as B, and this 8 is as it is. So 5EB8 is its equivalent decimal value. Multiply the fractional part decimal number by 16. Integral part of resultant decimal number will be first digit of a fractional hexa number. Okay, sorry. And repeat step 1 using only fractional part of decimal number, and then step 2. Okay. So the same thing in a fractional part, what we have to do is divide the whole part as it is, and this fractional part here to multiply into 2, and in an octal multiply into the fractional part is multiply into 8, and in hexa the fractional part is repeatedly multiplied by 16. Remove the overflow. Okay, take down the overflow as a first number and take the fractional part for next calculation. So this is the logic here. Okay, rules for converting from decimal to binary with fractional part, and from decimal to octal with fractional part, and also the next one is decimal to hexadecimal with fractional part. So in the same way they have given some sums. Okay, work out this problem. 123.25, this is a decimal value. Okay, this is a decimal value where they are given as x. So x means you have to identify. So how will you convert this decimal number with fractional part into octal, binary and hexadecimal value? So how you will convert this, that you have to mention it. So take down this 123 the whole part and divide it by 8. Okay, and then take this 0.25 into 8. So 200 here. So the process stops here. So take this 2 as here, and 173 bottom to top. Okay, so this is its equivalent octal value. So 173.2 is its equivalent octal value, and here binary value similarly divided by 2. Okay, so 0.25 into 2, 0.50, and so 0.25 into 2, that is 0.50, 0.50 into 2, that is 1.00. So when 00 receives, you have to stop the process. Take down this only top to bottom, the fractional part 0, 1. So that is 41011.01 is the answer. Okay, so in the same way you have to do it for a hexadecimal. Divided the 123 by 7. So 7 and 11. So 11 is represented as B. 11 is represented as B. So 7B is its whole part. And for the fractional part, 0.25 multiplied by 16, 4.00. So when 00 comes, it stops the process. Take only this 4 as its decimal part. Fractional part for hexadecimal is 7B.4. Okay. So this is a very easy and important method. We should work out